Hello and welcome to my channel again. So in this video we are going to discuss about the quantum operators, that what exactly the quantum operators are and why the quantum operators emerges in the quantum mechanics, that what's the uses of the quantum operators in the quantum mechanics. So without wasting the time, let's start the concepts of the quantum operators in the quantum mechanics. So here the topic quantum operators. So to understand the quantum operators, first of all we have to understand operators. As I previously also explained the concepts of operators in my previous video, but I am going to do a quick recap of the operators. So what exactly the operators are? So operators are generally the mathematical functions, mathematical entities that generally Operators are those mathematical functions and entities that generally transform a particular function into some another function. And I also take the example of the d by dx very clearly, because d by dx is also an operator. So it acts on some functions and gives some other functions. So we can call them as operators. So what's the use of the operators in quantum mechanics arises? How the use of the operators in quantum mechanics arises? So let's see. What happened is that just like in classical mechanics, just like in classical mechanics, if anyone asks you to predict the momentum of the particle, if anyone asks you to predict the momentum of the particle, how you can define the momentum of the particle? Very easily by its mass time velocity, and this is the general expression of the momentum in the classical mechanics. But in quantum mechanics, this is not the case. But in quantum mechanics, this is not the case. Quantum mechanics is based upon probability. Quantum mechanics is based upon probability. So in quantum mechanics, what happening is that here is a very fundamental equation. Here in the quantum mechanics, there is a very fundamental equation which I'm going to write here, a very fundamental equation in the quantum mechanics, which is the minus h cut square divided by 2m, and here it's a second order differential equation, and here is the del square psi and divided by del x square plus v psi plus v psi is equals to the I, or the iota term, you can say I h cut del psi upon del t. So this is a very fundamental equation in quantum mechanics known as a Schrodinger wave equation. So Schrodinger published it when he realizes that exists called wave particle duality, that waves or particles, like particles also behave like waves, that was discovered. So now Schrodinger published this particular wave equation in less than 1 month. So what happened is that, first of all, I will try to explain this equation. So first of all, this is a differential equation. So what exactly the differential equation is? So differential equation is an equation where there's existed derivative. What exactly derivative is derivative is the differentiation. So don't confuse between the differentiation and the derivative. Both are the same thing. So what happening is that this is a differential equation where there is a derivative. So that is followed by the Schrodinger wave equation. So what happens when you solve it? As you all know that there is a solution of any of the differential equation, like force is equals to the mass into acceleration. So this is a typical formula of the Newton's second law, but this formula can also be written into its differential equation form. So what's exactly the solution of this particular differential equation published by the Schrodinger? So the solution of this particular equation, what known as the psi. As you can also see here in this equation, there's also exists a psi. So what is psi? So psi is a wave function. So now there is an important concept emerging in the quantum mechanics, that this is a wave function. What exactly the wave function is some of the mathematical entities. So we are trying to explain the wave function here. So here it's a wave function. Wave function. So what's this wave function is? So the thing is that when you solve this differential equation, you will get a solution, and that particular solution is what known as the wave function. The wave function is generally a mathematical entities which contains some mathematical formulations, as I previously said. Quantum mechanics is based upon probability, so you cannot directly apply the formula of mass into velocity in quantum mechanics. You cannot generally directly apply this formula of mass into velocity. So there is an indirect way to know about the momentum and the any type of the physical quantities, maybe the kinetic energy of the particle, if potential energy of the particle if it exists. So the thing is that you got the wave function. So wave functions contain some mathematical entities. It contains some mathematical entities. Mathematical entities. Now the concept of operator arises in quantum mechanics. As I said that you cannot directly apply the formula of momentum to know the momentum of the particle. So here exists an important concept, quantum operators. So what happened is that solving this differential equation gets the wave function, and when you apply some of the operators in wave function, it will gives the correspondingly values. Like when you apply the momentum operator, to the wave function, as I said that wave function is a mathematical form, it contains some mathematics involved in this. So if you apply this particular momentum operator, so operators in quantum mechanics is written as p hat. So this is a momentum operator. So what happens is that you apply this particular momentum operator to the wave function and you will get the value of the momentum of the particle. So operators must have some sort of mathematical function. Yeah, so the momentum operator also is a complex entity. I will tell you the value of this, and I will tell you the momentum operator formula, which is the minus iota h cut del upon del x, or the partial derivative you can say. So this is the formula of the momentum operator. It means when you apply this particular momentum operator formula, where to the wave function, to this particular psi, when you apply this to this particular psi, what you will get is about the momentum. Why I have written momentum in some sorts of brackets? So I will tell you this particular entities in the next video. So for time being, this is the expectation value of momentum. So what exactly the expectation values of momentum, what the expectation values are? So expectations values are generally the average of all the values, or you can say that, but in the next video I'm going to the detailed explanation of this particular expectation value. So for now, we are concentrated to only understand the topic of the quantum operators. That when you apply this particular momentum operator to the wave function, what you will get is about the momentum. And this is true for any other thing. Like first of all, you want to know about the kinetic energy of the particle. So what happens is that you will just apply the kinetic energy operator. You will just apply this particular kinetic energy operator to the wave function. What you will get is the idea about the kinetic energy of the particle. So here the concepts of quantum operators arises. That in quantum mechanics, you generally do not directly know about the momentum or any of the physical quantities as you do in the classical mechanics. What you have to do is that in quantum mechanics there exist special operators of every quantities. Like for knowing momentum, there exists a momentum operator. For example, to know about the kinetic energy, there exists a kinetic energy operator, and different types of operators may exist, position operator. So these types of things exist. That's why the concepts of quantum operators are very important, because without the quantum operators, you cannot generally predict the any type of the physical quantities of the particle. So this is the very important concepts in the quantum operators. Very important concept in the quantum operators. So now quickly recap this, that why I have turned. I have just explained that what operators are, as I have explained that operators contain some mathematical functions. Like you can see here in the example of the momentum, you can see here it is also some of the mathematics. Iota, h square, del by del x, it also contains some mathematics, and when you apply this particular to the wave function, you will get the momentum. Now we try to explain the difference between the quantum and classical. As in classical mechanics, what we do is that we just apply the formula of momentum as mass into the velocity. We know the velocity of the particle, and that's the case. No, in quantum mechanics this doesn't happen really. In quantum mechanics, generally the velocity is not well defined. All the things are based upon the expectation value. So the expectation value is also the core of the quantum mechanics, basic quantum mechanics. So I will try to explain the expectation value in the next video in a very detailed manner, that how this comes. Next, we try to explain the Schrodinger wave equation. So this is the Schrodinger wave equation, but there's existed two type of a Schrodinger wave equation: time independent and time dependent. So I will also go deep into the time dependent and time independent Schrodinger wave equations in some later videos. So for any type of person, let's say this is in formula of the Schrodinger, that's formula that is Schrodinger wave. But I want to explain some bit more about this, that what exactly this formula. So I want to tell that generally this is the, you can say that, the kinetic energy of the particle. It means now you can see that here, that the Schrodinger equation is just kinetic energy plus potential energy is equals to the total energy, is equals to the total energy. So this is the Schrodinger wave equation. I will try to explain it in a more detailed manner in the next video. So for now, our core concept is about the quantum operators, that what exactly quantum operators are. So every physical quantity in quantum mechanics has its own operators that acts on the wave function and gives off the value. And what wave functions? It can be any physical mathematical entities. So I will write down here one example of the wave function so that you can understand it, that how can we generally do this. So I am going to write here psi x is equals to, psi is a function of x, is equals to root here we can root under 2 by a, and here we can root under 2 by a sine n pi x divided by a. So this is a wave function, you can imagine. So if anyone ever studied about the quantum mechanics previously, you can easily identify that this is the example of the infinite square wave. Oh, what's this infinite square wave? So I will try to explain in another video. So you can think of wave function as this. So it means when you apply this particular momentum operator formula, to this wave function, you will get the value of momentum. But you cannot directly apply it. There is some of the rules. That is used to determine the value of momentum, which is related to its expectation value, that I'm going to explain in the next video. So for easy explanation, you can think this, that you just apply this particular momentum operator. You can just apply this particular momentum operator to the wave function, and you will get the value of the momentum. But remember, directly we cannot apply. But there is a special formula for applying this. I am just trying to explain it so that anybody can understand it easily. Exactly, this is not the case that you directly apply the momentum operator formula to the wave function. So in this video, we have discussed about the quantum operators concepts, But yeah, quantum operators acts on the wave function. What is wave function? Wave function is a mathematical entities that contains all of the information about the particles. So if you want any type of the other quantity, any type of the quantities of the particle, you can just apply its correspondingly operators to that wave function to know about the particles, what's exactly the particles momentum will be. You cannot exactly measure the momentum, I'm just saying it to you so you can understand this, so you can know about the expectation value of the momentum or any other things. So here in this video we try to explain small concepts called the quantum operators, that what exactly the quantum operators are. But remember, quantum operator is not complete sets, so I have to understand the expectation value. So in the next video I am generally going to explain the expectation value, and the only thing that you have to understand in this video is that you apply this particular momentum operator formula to the wave function and you will get something what known as the expectation value of momentum, or you can easily say in the value of the momentum. So this is the case in the quantum mechanics, that in quantum mechanics you cannot exactly do the same things as in the classical mechanics or in the Newtonian mechanics, you can say. So this is a video where I discuss about the quantum operators. Next video I will discuss about the more of the very interesting concepts in the quantum mechanics. So if you have any doubt related to this quantum operators or quantum mechanics, you can comment down those doubts. So thank you for watching my video about the quantum operators.